Hi everybody, welcome to another episode by the Opinionated Science Educator. In today's video, I'm going to be comparing the Physical Sciences CAPS curriculum with the Technical Sciences CAP curriculum. That is so that anybody who is doing technical sciences and requires support or help can know what sections are new and how the rest of the curriculum has been rearranged within the Technical Sciences curriculum. We will start by looking at the section or the knowledge area of mechanics. In both the Technical Sciences and Life Sciences, sections of mechanics are done in grade 10, 11 and 12. So what we'll do is we'll look at the Technical Sciences, the units, measurements, scientific notation, working with formula, rates and so on is explicitly included in the Technical Sciences curriculum. In both curricula, there is an introduction to vectors and scalars and motion in one dimension. In other words, understanding velocity, displacement, and acceleration, and possibly looking at motion with the equations of motion. One of the key differences is how forces is dealt with in the Technical Sciences curriculum. In physical science, vectors in two dimensions and force are all looked at in grade 11, whereas in the Technical Science program, forces are introduced, including calculating the resultant and equilibrium, drawing force diagrams. Then in grade 11, then using the theorem of Pythagoras, you look at forces in two dimensions, including looking at the resolving forces into components and frictional forces. And then in grade 12, you look at Newton's laws of motion, whereas that's all covered in grade 11 in the Physical Sciences curriculum. So as I said, all of forces is covered in grade 11 in physical sciences, but in the Technical Sciences, force is covered over the 3 years of your FET program. Momentum and impulse are both looked at in the grade 12 curricula for physical science and technical science, and that would include collisions, elastic collisions and inelastic collisions. In both the Physical Sciences and Technical Sciences curricula, the next section is work, energy, and power, where you look at the definition of work, what power is, and the work-energy theorem. In the Technical Sciences curriculum, in grade 10, you look at the rotational effect of force. In other words, the moment of force, torque, the law of moments, which is new. Included in that is looking at things like examples of simple machines, most of which work on the rotational force of, or the rotational effect of force. So this is new in the Technical Sciences curriculum, and it is not covered in the Physical Sciences curriculum. What is also new to the Technical Sciences curriculum is looking at the deformation effect of a force, that a force can change the shape of a body. So looking particularly at Hooke's law, elasticity, the deforming force, the restoring force, shear and strain. These are all new in the Technical Science curriculum. What is also new is the section on fluid mechanics, such as viscosity and the effect of temperature on viscosity, hydraulics, which is pressure in liquids and upthrust, and Pascal's law and how this is used in hydraulics. So this section is also new in the Technical Sciences curriculum. So as you can see, some interesting new topics. Now looking at wave, sound and light, which in the Technical Sciences curriculum, in the summary, they've only labeled as waves and sound, but there is light also in the sections that we will be looking at. In physical sciences, again, this is covered in all 3 years of the FET program, but in the technical sciences, this is only covered in grades 11 and 12. Now, if we look at the sections, transverse pulses, pulses on a string, longitudinal waves, transverse waves are all covered in grade 10 in physical sciences and the same in the technical sciences. However, electromagnetic radiation, which is covered in grade 10 in the physical sciences, is now included in the grade 12 component of wave, sound, and light in the technical sciences. So this is now in grade 12 for technical sciences, whereas in physical sciences, it's covered in grade 10. Geometric optics is covered in grade 11 in the physical sciences, and light, such as refraction, reflection, which is geometric optics, and the critical angle, internal reflection, are covered in grade 12 in the technical sciences. The Doppler effect is the grade 12 physical sciences section on wave, sound, and light, but it's not included in the technical science curriculum. So the Doppler effect is not included. So those are the differences. As you can see, wave, sound, and light is covered in 3 years in physical sciences. And in the technical sciences, it is only covered in grades 11 and 12. You don't do the Doppler effect. You don't look at 2D and 3D wave motion, which in the physical sciences is needed to understand the Doppler effect. But for technical sciences, the wave, sound, and light is covered in grade 11 and 12. Now, I would just like to point out that elasticity, especially Hooke's law, is a periodic motion. So I'm a little bit surprised that the link is not made between periodic motion and pulses and waves in the technical science curriculum. As I said, the oscillations in the spring are in fact periodic motion. So it's important to understand that there is a link there between the mechanics and the wave, sound, and light. Well, that's the 2 sections of physics that I'm going to be looking at in this video. So I hope that you found this video useful in comparing the 2 curricula. And if you're doing technical sciences, I'm looking forward to posting videos on some of the topics. They are topics that are interesting and practical and applicable to our everyday lives. If there's a particular topic that you feel you really need help with, subscribe to my channel, and in the comment section, just post a comment telling me which topic you'd like me to look at. So until next time, the Opinionated Science Educator signing off.